Good evening, friends. Welcome to today's lesson on trigonometry for fifth class pass-out students. Uh, Yesterday, I was talking about uh, trigonometry. Yeah, I started trigonometry yesterday. Shankar,
Sir,
yesterday I talked about I started the topic trigonometry, right? In that I let me recall the main points in that lesson. Okay, I said a triangle is a convex figure. A it's a convex it's a convex closed polygon. Right? Uh, are you able to watch? Shankar,
yes. Yes.
are you able to watch the board? కనబడుతుందా board?
Agan.
Okay, okay. Yesterday, I was talking about a triangle. I said a triangle is a closed convex figure, right? A triangle is an example of a closed convex figure, right? Uh, what is a convex figure? Yeah, a convex figure is that in which if you take any 2 points in its interior and if you join them with a line segment, that line segment also belongs to that. That line segment also belongs to that. Okay. So let me draw it clearly. Right. So yeah, I have taken these 2 points. I have taken this point and this point, and I joined them. I joined them with a line segment. That line segment must be in the interior. If I name this triangle ABC, okay, in that I am taking 2 points P and Q, and I am joining P and Q with a line segment. The line segment joining P and Q must be inside in the interior of ABC. This portion, all these points form the interior of triangle ABC. Okay, in that you take any pair of points, arbitrary pair of points, you join them with a line segment. That line segment must lie inside the interior. Okay, in the interior only. It should not cross beyond the triangle. Such a polygon is called convex. I want to give an example of a figure which is not convex. Look at this figure. This figure is a polygon. Okay, I can name this. I can name this. This may be called P. This point may be called P. This vertex can be called Q. This is R. This is S. So this is polygon P, Q, R, S. Okay, you have 4 line segment as boundary for this polygon. And if you take the or 2 points, 1 point here and 1 point here, and if you join them with a line segment, you get this kind of a line segment. Okay, I'm taking 2 points, 1 point here and 1 point here. Okay, so I'm joining. You may call them capital A, capital B. I'm joining AB with a line segment. The points A and B with a line segment, and this portion of the line segment. Okay, this portion is not contained in the interior of this polygon PQRS. Okay, these points come from the complement of the polygon PQRS. Okay, these points don't belong to the interior of the polygon of PQRS. Therefore, PQRS is not convex. Okay, are you understanding, Aditya? Shankar?
हाँ तुम्हारे
So the
हाँ
are you understanding that PQRS is not a convex? Is not convex? Okay.
yes.
So the triangle becomes convex, whereas this kind of a figure, this though it is polygon, it is failing to be convex. Okay. And then I will give an example of a figure which is not open, which is not closed. This figure is closed. A triangle is closed. A triangle is closed. Whereas if you take this kind of a figure, this is one line segment. This is no, not this. Yeah. This is in the line segment, and this is in the line segment. So for me, this is a polygon. For me, this is a polygon. This polygon, right? I can name this. I can name this. This is some we call TUV. I can call it TUV. Okay, this is polygon TUV. This polygon is not closed. This is non-closed polygon. Non-closed. Why? Because this is initial point. We started from this point T and ended up with the point V. Okay, this is terminal point, the last point. This is the initial point, the first point. These two are not coinciding. That is why this polygon is not closed. Okay, whereas if you take a triangle, for example, triangle. If you take triangle ABC, as in this figure, this is closed. You start with A, you travel on the line side AB, reach B, and again you travel on the side BC, reach C. From C, you travel along AC to reach A. So A is initial point, and the terminal point is also A. After traveling along the boundary of this triangle, along the perimeter of this triangle, you are coming back to the initial point. So in this figure, the initial point is equal to the final point, the terminal point, okay, or end point. So this figure is called closed, whereas this figure is not closed. You have to understand the difference. You have to differentiate between these two. Okay, you have to distinguish between these two figures, right? That's what about
Sir.
convex figures and closed figures. Okay. Well, yesterday I was also talking about. I was also I was also talking about the sexagesimal system. Okay, let me take in the slide. Uh, yeah. So so I have taken the X-ray plane. Oh, వాయిస్ తగ్గించు శంకర్ బహుశా వాయిస్ దాన్ని ఏంటి హమ్మింగ్ ఏదో అంటారు అది క్రియేట్ చేస్తుంది వాయిస్ హమ్మింగ్ ఏదో క్రియేట్ చేస్తున్నట్లుంది శంకర్ నీ దానికి వాయిస్ కొంచెం తగ్గించిన అన్న ఓకే యా
అది యాక్చువల్లీ డబుల్ స్క్రీన్ పడిపోయిందండి.
ఎస్ 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 శంకర్
అది
శం-
అది
శంకర్
యాక్చువల్ గా చెప్పండి తాతగారు.
Okay, okay. Now, yesterday we were
ఇది
talking about the X-ray plane, and we know that these two coordinate axes, x-axis and y-axis, they intersect. No, 1 minute. Yeah, they intersect at the point origin, right? Hmm. Okay. Right. So let me, this is x dash, this is origin, this is x, and this is y, and this is y dash. Okay. X axis is x dash O x, and y dash is y O y dash. These two lines, the horizontal line and the vertical line, they are intersecting at the point O. We call this origin. We call this origin. Okay. And its coordinates are 0, comma 0. Okay. And we know that this positive x-axis, OX, right? Let us see what is complete angle at this origin. Means you take OX as the initial ray and start moving in the positive direction, in this direction. Okay? Till you return to OX. Okay? So you start on OX, you move in positive direction. Positive direction means anti-clockwise direction. Positive direction is called anti-clockwise direction. Okay, so that is called the positive direction. In that direction, you move from the positive x-axis in the right, and you move till you reach OX back, the positive x-axis back, and then the angle subtended is 360 degrees. That is given a measure. That angle is called complete angle. That angle is called complete angle, and it is given measure of 360 degrees. Do you agree, Aditya? Do you understand, Aditya?
Yes, sir.
Complete angle ante
Yes,
ade
sir.
kada?
Yes, sir.
Okay, okay. So, complete angle also becomes angle at a point. It is at an angle at a point. Okay, at a point. Yeah. So at a point, right? And then we made this 360 degrees into 360 equal parts. So what we get is 1 degree. Okay, and then we subdivided this 1 degree into 60 equal parts. Okay, and then we got 1 minute. This is called 1 minute. Okay, and then we subdivide this 1 minute into 60 equal parts. Each is called 1 second. Okay, this is what we did yesterday, right? We gave a measure. We gave a measure for the complete angle. That is the angle at a point. Okay, that is we said it we decided its measure to be 360 degrees. Okay, okay, దానికి ఒక కొలతను ఇచ్చామన్నమాట. Right, and then we divided that complete angle 360 degrees into 360 equal parts. Each is called 1 degree. Okay, and that 1 degree is subdivided into 60 equal parts. Each is called 1 minute. Okay, and then we subdivided this 1 minute into 60 equal parts. Each is called 1 second. That's how we subdivided this degrees into minutes and minutes into seconds. And this process is called, this way of subdivision is called sexagesimal system. It is called sexagesimal system. Okay, of measuring of an angle, system of measuring an angle. Okay, here we are right, measuring angles. Okay, and we define one complete angle to be 360 degrees. Its 360th part is defined to this 360th part becomes 1 degree, and that is defined to be 1 degree is defined to be 60 minutes. 1 degree equal to 60 into this, that is 60 minutes it is. That's how we define minutes. And then 1 second is what? 60 into 1 second becomes 1 minute. So 60 seconds make 1 minute. Okay, that's how we define the relation seconds out of minutes. Okay, this method of measuring angles is called sexagesimal. Sexa means into 60. Right here, 1 unit is divided into 60 equal parts. 1 unit is divided into 60 equal parts. So it is sexagesimal. Decimal means 10th part. Sexagesimal means 60th part. 6 into 10. 60th parts. Okay, that's how this method of measuring angles is called sexagesimal system. There is another equivalent measurement system of measuring angles, that is called centesimal. Centesimal. Okay, and in this what we do is, this is centesimal system of measuring angles. In this what we do is, we take this complete angle is 300, and complete angle is how much? Shankar, are you there? Shankar, Aditya. Okay, one complete angle is 360 degrees. This is defined to be 400 grades. Okay, G for grades, 400 grades. Okay, 360 degrees, which is complete angle, is defined to be equal to 400 grades. So this gives us 1 grade is equal to 360 by 400 degrees. Okay, right? This is also written as 1 grade, 1 power z. Okay, and then yeah. one grade is further subdivided into minutes. This is defined to be 100 minutes. You notice one point. In sexagesimal system, you have minute. That is 68th part of a degree. But here, this is different. This minute is different. Okay. Right. See what happens. This you may simplify. 0 cancel. 36 by 40 means this is 9 by 10. It is 0.9. Right. 0 cancel. 36 by 10 is 3.6 by 4 means 0.9 degrees. So one grade is 0.9 degrees here. Okay, and then one grade is subdivided into 100 minutes. These minutes are different. This is in centesimal system. This is in sexagesimal system. And then yeah, so this becomes how much? So one grade means 0.9 degrees by 100. So this is equal to no. From here I am calculating 1 second. This is 1 minute, I'm sorry. This is 1 minute. 1 minute. Okay. From here I am calculating 1 minute. 1 minute is 1 by 100 of a grade. Okay. Yeah. So out of this 100 minutes are equal to 1 grade. So this can be thought of 100 into 1 minute. So you take 100 to the left hand side. So 1 minute becomes 1 by 100th of grade. Okay. And this is 1 minute. This is 1 minute. 1 prime. Okay. Like in power you have to write 1 minute. And you have to read 1 minute. This is 100th of grade. Okay. 100th part of grade. Okay, now one grade is how much? One grade equal to 0.9 degrees by 100. So this is equal to how much? Is equal to 0.9 by 100 is 0.009 degrees. Okay, and then and then we introduce seconds also here. 100 seconds make 1 minute. This is read as 100 seconds. This symbol stands for seconds in this centesimal system. Okay, 1 second is defined as 1 minute is defined as 100 seconds. So this is 100 into 1 second. Therefore, 100 into 1 second. Okay, therefore, for second I have taken double prime. It is called 1 second. So 1 second becomes how much? 1 second is equal to 1 by 100 of a minute. Okay, you bring 100 to left hand side. So 1 second is equal to 1 by 100th of minute. That's what I wrote. 1 by 100th of minute. Okay, and for 1 minute I can take 0.009 degrees. 0.009 degrees by 100. Okay, for 1 second, 1 minute I can take 0.009 degrees. So this is equal to by 100. It becomes 0.409 degrees. Okay. So 1 second is equal to 0.409 degrees. 0.009 by 100 is 0.409 degree. Okay. So this way of measuring angles is called centesimal. Centesimal. Okay. Because here this one grade is divided into 100 equal parts to get 1 second. Okay, and then right, yeah, the 100th part of a grade is defined to be 1 minute. The 100, yeah, one grade is subdivided into 100 equal parts. Each is called 1 minute. So 1 minute is the 100th part of grade, and then 1 minute is further subdivided into 100 seconds. So 1 second is 100th part of 1 minute. Okay, so 1 second is 100 part of 1 minute. So that's how here 100 plus roll means it is, that's how these subdivisions are formed by using 100. That's how the centesimal name has come. Centesimal means cent stands for 100. Okay, so 100 parts are taken here. So this system is called centesimal. Cent stands for 100. Okay, whereas the other one, in that 68 parts are taken. So this is called sexagesimal. Okay, and you can compare. The minute here is larger than the minute here. The minute in sexagesimal is larger than the minute in centesimal. Similarly, the second in sexagesimal is larger than the second in centesimal. That you can verify. I just mention and then move to numerical problems. Yeah. So what we are doing, we have taken 360 degrees, and this is subdivided into 368th part to get 368th part to get a degree, 1 degree. Okay, and yeah. So this 1 degree is further subdivided. Okay, into uh, into 60 equal parts to get 1 minute, and this is further subdivided into 60 parts to get seconds. Okay, so this is what is meant by 1 second. Out of 1 degree, you are taking the 68th part, so you get 1 minute. Out of this minute, you are taking 68th part, so you get 1 second. Okay, so yeah, first let me compare minutes in centesimal and sexagesimal, and then I move to seconds. Okay, yeah, that may look easier. Okay, yeah. So what we are doing, this 360 degrees is subdivided into 400 grades, 400 parts, and each is called 1 grade. Okay, 1 grade, and then this 1 grade is subdivided into 100 equal parts. Each is called 1 minute. So this becomes how much? This becomes, right? 0, 0 cancel. 6 by 40 means 3.6 by 10 is 0.9. Okay, so this is 0 0.9, 0 0.9 degree. Okay, 1 grade is 0 0.9 degree. 1 grade equal to 0 0.900 cancel. 36 by 40 means 0 0.9 degree. This is degree. Okay, that should be a bit smaller. Yeah. Okay, and then that by 100. So 1 minute becomes how much? This is 0.009 degrees. Okay, and what happens in sexagesimal? 1 degree is subdivided into 60 equal parts to get 1 minute. So this is approximately how much? 1 by 60 is how much? 0.1 by 6. 0.1 by 6 is 0.1. 10లో 6 పోతే 4, 40, 6, 36, 40 అట్లా వస్తూ ఉంటుంది. It is this much. So degrees. 0.16 recurring degrees is 1 minute. We compare these two. This is 0.009 degrees. This is 0.16 degrees. This is definitely larger. This is larger. This is larger than this. Okay? This is larger than this. That's how the minute in sexagesimal is larger than the minute in centesimal. Similarly, you can compare the seconds also. What is second? Out of this, you are taking 68th part. So to get 1 second. The 68th part of 1 minute is 1 second. Okay, means it is 0.16 degrees recurring by 60. This becomes how much? 0.016 by 6. 0.16 by 6 degrees, recurring degrees. Okay, this becomes how much? 0.002, and then 16, 7, like that it comes. Okay, degrees. Okay, so one second is these many degrees. How about here? This is 1 minute, and this is subdivided into 100 equal parts to give us 1 second. So you divide this by 100, you will get 0.00009 degrees. Okay, you divide this by 100 to get 1 second. So 1 minute is subdivided into 100 equal parts. Each is called 1 second. So 1 second is equal to this divided by 100. So this, right? This is divided by 100, so this also should be divided by 100. That is, this point shifts to left hand side by 2 more digits. So it is 0.00, instead of 0.009, it becomes 0.409. These many degrees. Okay, see, this is 0.0027, this is 0.409. So definitely this is much larger. This second value is larger than this second value. Okay, this is, yeah, this is 1 second in sexagesimal. This is 1 second in centesimal. This is 1 second in 1 second in sexagesimal. Okay, in sexagesimal, 1 second is equal to approximately 0.0027 degrees, whereas in centesimal, 1 second is equal to 0.409 degrees. This is much larger. Okay, you have two places occupied by non-zero digits, 217, whereas those are zeros here. So definitely this is much larger. This is more than how many times? 3 times larger than this. Okay, so that's how you can compare, right? Yeah. Okay, I will come back to another topic which we were discussing yesterday. I'll move to this line. Yeah. So yeah. Mm, right. We yeah. We were talking about the sector and its arc length. Okay, let us consider a sector. Let us consider a sector. Okay, uh, uh, right. Then yeah, let us join these two with a circular arc. It is something like this. Sector is something. It is like a cone. Okay, right. Here, this you may just read it on. Right? Yeah. This is sector. What is sector? Uh, what is sector? It is part of a circle. What is sector? It is part of a circle. Okay. Of course, I have to take much larger. Yeah. Okay. Yeah, this is radius. So this is radius. Here, what is radius? This is radius. This is the radius. Okay. Uh, I mean, take for the large. Okay. Yeah. So what is radius? This is radius. Okay, let me take the radius to draw this sector. Okay, yeah. So sector means you let me name these points: capital A, capital B. I'm taking a circle with center O and radius small r. Okay, and I'm considering, yeah, I'm considering these two radii and this portion of the sphere. This I'm sorry, this portion of the circle AB, the curved portion of this circle AB. So that part is called sector. This is called sector. Sector. Okay, out of this circle, I'm taking the portion formed by this arc from A to B. Okay, so I'm assuming this is A, this is B, and this portion is same as this. I'm not able to draw exactly, okay, because this is digital writing, so it makes it like this. Okay, yeah. So this is curved part of this circumference AB, that is called, let its length be smaller. It is called arc. It is called arc. Okay, arc of this sector. Okay, or curved portion of this sector. Okay, and then this arc and these two radii form the sector. Okay, that is the perimeter of the sector. This radius, this is O, this radius AO, radius OB, and this arc length L. This arc length L, uh, this arc length L. Uh, శంకర్. శంకర్. నో. కంటిన్యూ ప్రోగ్రెస్. ఆపేసాడు. శంకర్. హలో. శంకర్. శంకర్. అమ్మా శంకర్కి ఇవ్వండి ఒకసారి. వాడు ఆపేసాడయ్యా. వాడు అరగంట ఏదో దాటింది. అరగంట దాటింది కదా, ఆపేస్తాడు వాడు. డబ్బులు కట్టమంటున్నాడు. సరేలే, నేను నీకు ఓరల్ గా చెప్తాను, నువ్వు ఫాలో అవ్వదు కానీ, సరేనా? బై ఫోన్ చెప్తాను. నువ్వు నీ వర్క్ షీట్ తీసుకో, అది నువ్వు నాకు పంపించావు కదా పీడిఎఫ్, అది తీసుకో. ఒక 2 నిమిషాలు కనెక్ట్ అవుతా, సరేనా? వీడు ఇంకా ఇవ్వడు. వీడు ఇంకా ఇవ్వడు. అసలు జనరల్గా 1 అవర్ వరకు ఉండాలి. నేను 1 అవర్ 15 మినిట్స్ బ్లాక్ చేస్తాను. ఇవ్వాలి వాడు. డబ్బులు అడుగుతున్నాడు. సరే, తర్వాత చూద్దాం.